Yeah, Annie's having trouble switching from my camera to Susie and
Got
Mika's
it.
cameras.
Got it. Got it. Got
Yay!
it. Got it. Got it. Got it.
There we
Hey,
go.
there's me. Okay, now we need a split screen.
Dun, da, da, dun, 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 dun. Yeah. Well, you're on the live
I'm
stream.
on. Now we just got to get both of us on. There we go.
I'm totally watching on here to find out what's going on.
That's what I'm doing too. I'm watching. There's a delay. It's weird.
Oh, hey, look there. I'm there too. There we go. We've got a thing. Hi. Yeah, it's switching back and forth. We might as well just go for it.
Okay. Okay. Well, hi, everybody. I'm producer Susie, and I'm jumping back in to do a little bit of moderating to give Annie and Dave a little break. And I am here with Dr. Mika McKinnon. And why don't I let her tell you a little bit about what she does? So, Mika, tell us, who are you? What do you do?
All right. Well, you accidentally gave me a promotion. I'm a master, not a
Oh,
doctor.
you're a master.
I have a master's.
That's what I am. So we're cool. We should be doctors. There we go.
No. Master's in disasters is the best job title ever. I will never. I can't get an upgrade unless I go for a doctor if doomed.
That's awesome.
I've hit my max just by the name title. So I'm a geophysicist, and I feel guilty because I'm not wearing my little ring that indicates I'm a Canadian geophysicist who took wedding vows to my work, which is it's one of those secret Canadianisms. Now you know about it. You can look for the little silver ring and have like access to our secret special club of geoscientists and engineers.
I was at Dragon Con. I saw you tell that story.
Yeah, it's a great one. And I work with rocks, which is actually kind of surprising for a geophysicist. Often we don't actually touch rocks. I specialize in disasters. I look at landslides. And the link to CosmoQuest on this is at the moment I'm working with Project Espresso, looking at landslides in space. So how do we have landslides on asteroids? How do we do hazard assessment on asteroids? How do we figure out for something like the poor little OSIRIS-REx robot currently in orbit around Bennu trying to find that one safe space to land? Can we use what we understand about landslides here on Earth and apply it to other places to not squish the robot?
And it is hard, at least on Bennu, it was hard to find a place where there weren't rocks everywhere.
Yeah.
Our group knows that very, very well.
Yeah, it was way more rocks than anyone really expected there. It's a lot. It's a lot of rocks.
It was a lot of rocks. It was a little crazy. So, basically, let's just start off with what is your favorite disaster to talk about?
Oh man. I also work in science fiction. I work as a science consultant in the movie industry and the TV industry. If you ever watch Stargate, you know my handwriting really, really well. If you ever watch Sharknado, there is exactly one sentence of completely perfectly accurate science. I still don't know why they hired me, but that's okay. They paid me. It's good enough.
That's good.
Yeah, I've gotten to do science in all these sorts of interesting places. And because of that, I really prefer fictional disasters to real life ones, because then I can go over the top of here's all the possible things and all the unintended consequences and all the ways these things can come together, or more accurately, fall apart. And nobody actually dies, which is the best bit, because then it's just this warning, this foretelling of here's what could happen. And it gets people thinking about disasters. And it turns out if you even think about disasters and don't do anything else, just think what could go wrong, you actually respond better during disasters. So I like the fictional ones.
I kind of do too. I'm one of those people that kind of plans in my head when I'm thinking about things. I'm like, okay, if in this situation, what would I do? So when I read books or watch movies, I'm like, how would I react? So let's start off with like the most basic fictional disaster that you can think of, and just give us a description, because I would be interested to know where you start.
Like,
Maybe
every
start with the most likely one and then let's go to the crazier ones.
Oh, okay. So I mean, like almost every movie is going to have something go wrong somewhere. There's going to be a fire. There's going to be a flood. There's going to be a car accident. There's going to be someone forgetting their bag. There's going to be a power outage. There'll be a severe storm. Like, there's a lot of disasters that happen in movies all the time and aren't even worth being a plot point. They're almost just a hindrance on the way towards our heroes and heroines accomplishing their task. They have an obstacle along the way of locking their car keys in the car. Those are the sort of low level events that have very low impact, so they don't have a lot of intensity to them. The consequence is a bit of lost time, maybe some frustration, maybe a bit of cursing, not that much, and they happen fairly frequently. From there, you kind of step up to greater vulnerability, so more things at risk, more things that can be hurt, and bigger impacts that when those things go wrong, it's a larger thing. And those often turn into the actual plot centric point of averting this disaster, keep the bombs from going off, prevent the plane from crashing, get the mom to the hospital in time to have the baby, whatever this particular huge overarching conflict is, trying to prevent that from happening. We go from there up to things that are like city destroying disasters, a big regional earthquake, a severe storm that shuts down the whole city, the power grid has gone out, whatever. We go from there into the regional things. We've taken down the entire zone. The movie San Andreas was actually, they stole the earthquake from the Pacific Northwest and put it in Southern California to take out LA and San Francisco instead of Portland, Seattle, Vancouver. Aside from that, it was a pretty good earthquake. It's what I'd expect from a Pacific Northwest earthquake. I've lived through the Loma Prieta in San Francisco. It's one of the larger ones you get from that. It's not going to take out San Francisco and LA simultaneously. Also not going to have like tsunami coming off of it and taking out all of Embarcadero. But you could have that in the Pacific Northwest. Go from all the tornado movies are in that same classification. So like Twister and the Storm Chaser movies, Wizard of Oz, all of these are region impacting things where one area of a country is facing disaster, but not the entire country. You go from there up to the bigger scale regional, take out all of the United States, but Canada and Mexico will be just fine. Don't worry about it. To the global impactors, alien invasion, fall of an asteroid impact, deep impact, or asteroid or Armageddon or any of those. Black holes spontaneously coming through the solar system. Global warming movies fall under that classification. So all the cli-fi movies. Solar storms sometimes fall into that one. So things like Starshine or Sunshine, whatever it was called, or The Core, where we take out the magnetic field of the Earth and have all the solar radiation, instead of giving us pretty aurora and northern lights and southern lights, suddenly are like melting the Golden Gate Bridge. All of those would be like planetary ones. And then we get all the way up to like the solar system destroying events. Somebody has triggered a star exploding. That was a frequent thing that happened in Stargate. We had accidental destruction of solar systems, or purposeful, you blow up one star and suddenly everybody cares. Of course, happens with Star Wars in several of the movies now at this point. Is poor little Alderaan was definitely a planetary destroying movie. Yeah. And then after that, I guess there are some movies that also take out the entire universe, and that's the great big plot point, is keeping the universe from being destroyed. But those are kind of rare. That would be things like Avengers was take out half of all life in the universe, which honestly, the unsnap would be far more problematic than the original snap from like a disaster resiliency perspective.
Well, there's a bunch of them in there that I would love to kind of go back and deep dive into.
Absolutely.
I definitely want to
full scale. Like, where
I definitely want to get back to that unsnap, but not yet. Because there were some issues with that. So yeah, let's go back to the beginning and let's talk a little bit about the earthquakes and stuff. So what is the difference between like a Pacific Northwest and a Southern California earthquake? Because I'm a Southern person, so we don't have earthquakes much. And when they do, they're little. I mean, I know we've got a big fault line going through here, but it's not that active right now. It could very well surprise us. Yeah.
We're
You
late
can
on
tell me.
I'm allowed to get kind of maniacal about
Yes.
it, right?
Because I'm in Atlanta, so you can tell me what is the fault line through here doing, and how does that compare to the West Coast?
All right, so the entire surface of the planet is covered in tectonic plates. These are rigid but flexible, and they're moving around a couple centimeters a year, so about the same rate your fingernails grow. And they can pull apart, which would give you all of the spreading areas. These are typically underneath oceans, so the mid-Atlantic ridge is an example of that. It's pulling apart, new materials coming up in the middle. We get new oceanic crust. It's very young and very pretty and very exciting. They do sometimes happen on land. That'd be the East Africa Rift Valley is slowly pulling apart. It's like pulling silly putty apart at this point, and we haven't yet pulled hard enough to get the new crust forming in the middle. Same with Iceland. Iceland is on that spreading ridge and yanking apart. You can have places go side to side past each other, and that would be places like California. San Andreas Fault is the most famous example of this in the world. But places like Cuba, the entire Caribbean, have that same sort of side to side motion going on. Finally, you can have plates coming together. And if they're both continental plates are light and fluffy and they stay up. So if you have two continental plates collide, it's like crunching paper, except for instead of crunching paper, it's crunching mountains. And that would be the Himalayas, the join between India crashing into the rest of Asia. If you have a continental plate and an oceanic plate, one goes under the other. The oceanic plate goes underneath. It's called subduction. If you have oceanic and oceanic, the older, colder, denser oceanic plate goes underneath, and you get island arc subduction. So things like the Philippines. When that one plate goes under the other, the lower plate is full of cold, wet ocean sediment. And all that means that, first of all, you have cold, wet rocks under a huge amount of pressure. So you have cold metamorphism, and it turns your rocks green and blue. And I think, yes. Dun, 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 green.
Ooh,
That's
pretty.
greenstone, old ocean floor, old, cold, squished ocean floor. We call it greenstone and bluestone because we're very creative with our names.
You're as good or better than astronomers, so you're doing okay.
We're fantastic at it. It makes it really easy for me to remember the names because I'm a geophysicist, not a geologist. So you get the cold, wet ocean sediments under there. That water changes the melting temperature, which then means that you get more melt, and it pops up volcanoes all along that top ridge. Really violent, explosive volcanoes like Mount St. Helens or Krakatoa, or every volcano you've ever heard of and thought, ooh, that's a bad idea. That is, all of those are these intermediate volcanoes where it's wet sediment that has lowered the melting point, has come up, it's picked up a bunch of silica from the continental plate. So it's really light and buoyant and traps gas super well. And it's really viscous, so it makes these nice little pyramid-shaped volcanoes. Mount Fuji, another good example. All of which have these violent eruptions. This also means we get to use the term subduction leads to orogeny, where orogeny is mountain building. So that's one of our geologic joke sayings that sounds really filthy and isn't.
That's one of those you can get away with saying that word in public, and you're like, I'm not really saying anything bad. I'm talking about building mountains.
Exactly. Subduction leads to orogeny. Nobody thinks that is nearly as innocent as it sounds like it is, or something like that. I got my words. I have my adjectives in the wrong order. So you get those sharp, pointy volcanoes there. The other type of volcanoes you can get are just straight up ocean plate, no continental plate involved. They have low silica, so low levels of quartz and things like that. And because of that, their lava is hotter but runnier, and the gas bubbles out really easily. And because they're hot and runny, they make these dome-shaped volcanoes like Hawaii. Or Olympus Mons on Mars is a beautiful example of a shield volcano. Like, geologically speaking, it's Hawaii on a different planet, and lacking all the tropical plants. It's just the rocks. So if we pull all this together, if you're somewhere Southern California, plates going side to side, you get shallow, frequent earthquakes frequent being like every couple of decades, geologically speaking. You'll have a few in your lifetime. And they tend to be shallow and relatively low magnitude. So like magnitude 5, 6, 7, maybe an 8, maybe, but that's rare. And because they're so shallow, they'll shake like a single city worth of area. So like the Ridgecrest earthquake on 4th of July weekend out in the Mojave Desert was shallow. It was severe shaking in Ridgecrest. But by the time you got to LA, you could feel the earthquake. You could notice the earthquake. Everybody was very upset that their app didn't report the earthquake, but it wasn't actually severely shaking LA as well. In contrast, if you've got one plate going under another, that subduction zone, like in the Pacific Northwest, where we have all of our volcanoes, then you get less frequent earthquakes, like once a century or so, once every few centuries, and they're much bigger earthquakes. So we get the magnitude 7, 8, 9, and they generate tsunami, and they also feed our volcanoes. So that's the big difference there. So
that's a pretty big difference.
Yeah, and it's let's see, things underneath my sofa. Very briefly, this is kind of fun. So you go, how do you detect all these earthquakes? This right here is a little, it's called a raspberry shake. It is a seismometer with a geophone right there that can record any sort of earthquakes or seismic signals, any sort of vibration. It can pick up like the vibration of my washing machine or me stomping around or any of those things. And we can do earthquake tracking with them. At the moment, I had it powered down already. Poor like raspberry shake owners are currently going, oh my God, did you just like rip that poor honey right out of the wall? No, it's okay. It was off.
It was turned off.
It was already turned off because I'm packing it to go on a weekend vacation to the beach so it can pick up some seismic signals of waves crashing into a rocky shoreline. I want to get that seismic signal. It also, this particular one has an infrasound on it, which means it's picking up the pressure waves of air. So that would be something that we use for doing things like detecting explosive testing. Or in this case, what happens when you've got the hydro pressure of waves crashing into the shoreline and squashing all that air into the rocks. I want to pick that up. So I'm very excited to record some signals this weekend.
Is it called a raspberry shake? Does it have a Raspberry Pi in it? Is that what it's powered by?
Yeah, so this is a raspberry shake and boom. And it's actually a community science project. You can get them and then hook them up so it will display your information with everybody else who's got one on a map, and you can track down and actually pick up earthquake signals and everything. Ideally, you have it outdoors. I do not currently have mine outdoors. Again, I'm packing it up for the weekend. But yeah, you just leave it outdoors, turned on, and start noticing what sort of seismic signals you can get in your area. It's kind of amazing because like, you think of seismic signals being just from earthquakes, but in reality, geophysicists are spying on everything all of the time. Like you can spot traffic jams, you can see an out of balance washing machine, you can tell if you've got that noisy neighbor who stomps all the time. Yeah, they'll get picked up on one of these. There's a very, very famous paper among geophysicists about a very strange seismic signal in northern Canada or northern British Columbia that turned out to be a pair of teenagers getting better acquainted on top of the seismometer in the woods.
Oh dear.
Yes. Yes, where we thought it was vandalism. So sent out like the local police and the this and the that, and everybody comes converging on a pair of teenagers who thought they found a nice quiet place in the woods. Whoops.
So make sure there's no seismometer wherever you go. There you
go. Exactly. It turns out seismometers are often at the end of a nice trail into an isolated area. And so people think that this is a fantastic location for privacy. It's not. Really not.
No, that's kind of the opposite of privacy there. Yeah.
Yeah. That's whole teams of seismologists and geophysicists just watching your data being like, oh, really? Well, this is a very distinctive rhythm. So, I'm looking at the seismometers.
Yeah, I'm looking real quick to see if, because we've been getting a few questions. I want to see if there's any good ones I want to interrupt you with, because this chat goes by so fast, and I'm not a pro at doing all this. So I don't want to miss too many. So let me see. There were a couple in there. Oh, I missed it. Let's see. Okay, here's one. You'll probably roll your eyes. Does the USGS have some way to get people who look at their materials and go out and basically predict earthquakes to stop?
So this is actually a really interesting set of things because it ties together prediction versus forecasting and mitigation versus prevention. So when it comes to disasters, we can often do forecasting. We can probabilistically say this type of event of this type of intensity will happen within this time frame. And we can do that for all sorts of different disasters. We can do that for earthquakes, for landslides, for fires, for floods, whatever. And the fidelity of our forecast, how good we can constrain it down in terms of how often, how big, the location, all of that, a lot of that depends on how good is our data. So for earthquakes, we have a lot better data than for landslides. We've spent a lot more money on monitoring, a lot more money on research, on modeling, on having equipment out, on recording, on all of these things. With landslides, we really spend almost no money at all. For a while, the USGS budget was $100,000 a year for all landslide research in all of the US, where you're like, that's
not enough.
Maybe like with a shovel. So yeah. So it depends on how much money has been put into this. But even when you have a very good forecast, you still can't do an exact prediction of this event will happen at this time in this location. The only ones we can really do that with would be asteroid impacts. And even then, we can't do it far out. We can only do it when it's too close to do anything. Like maybe. And there's been a lot of smaller impacts that have just whizzed past without us even noticing. But something like earthquakes is way too complicated. Real life is like, we tease that rocks are simple. Like there's all sorts of jokes about dumb as a rock or rocks for jocks or any of like, it's this stereotypical thing. Geology is not a real science was a Big Bang Theory joke. Turns out real life rocks are super complicated and really confusing. Like in a lot of ways that are deeply peculiar. So we can't actually go, this is happening at this exact time. That's the first problem. The next problem is prevention versus mitigation. Again, we can't fully prevent any disaster, but we can mitigate them. We can reduce the risk, and we can reduce the risk either through reducing the hazard or reducing our exposure. So to have something at risk means you have both the danger and something that can be hurt by it. You can have all the landslides possible on Venus, and we don't care because there's nothing there to get hurt. There's huge chunks of Mars that can have all sorts of storms go past, and we don't care because there's no robot. We only really have a risk when there's a rover or a lander that can get injured by the storm. Same thing here on Earth. If there's nothing around, we don't have a risk. So that's one way of dealing with it. It's just saying, hey, exclusion zone, nothing is allowed here at all. Therefore, we have completely eliminated the risk. And to do a sort of half version of that is something like every time there's great big huge storms that do severe inland flooding, since we know that climate change is happening, sea level rise is happening, these storms are getting more intense, the inland flooding is getting more intense. Maybe we should start setting our zones farther and farther back, abandon that shoreline, turn it into parks, turn it into farms, turn it into a daytime use only, reduce our exposure, and thus change our risk by building further back. So we can do things like that. And that's called retreating. We can try and hold the line, so we can establish what the risk is and just try and keep it exactly what it was, even if the natural physical phenomena are changing. So the equivalent of that is like build a wall. We can try and advance, push ourselves forward, build out new land. Or we can do nothing. Just accept that our risk is what our risk is. With earthquakes, we sometimes talk about things like what happens if you triggered an earthquake early, if you release that stress artificially. But first, that would mean we have to really fully, completely, totally understand what is happening. We're artificially and accidentally triggering a lot of earthquakes already anytime we do fraction or other subsurface injection, where we're adding pressurized fluid into the subsurface, and that's causing cracking of the rocks. That's literally what fracking is to fracture through hydropressure. And then lubricating it all so it moves around. At this point, Oklahoma has a larger number of small-scale earthquakes than California does. It's a little bit of a whoops on our part, unintended consequences. Don't worry, nothing is fine. Everything is terrible. So you can try and do that, but that means understanding what exactly is going on. And if you get it wrong and you trigger a way bigger earthquake and you kill everybody, that's on you. So we're probably never going to do that because the risk of getting it at all wrong is enormous. There's also the part of if you tried to trigger smaller earthquakes, you would need to trigger so many of them to be the equivalent of one large earthquake. Like it's orders of magnitude difference.
Sorry, I had a dog disaster going on behind me. Had to get him out of here for a minute.
A few years back on one of these, my hedgehog broke loose and escaped midway through.
All right, so let's get back to some of the fun stuff again.
Yes.
Just to tackle some of the silly things. Tell us a little bit about Sharknadoes.
Right.
And tell us what that one line of real science was in the movie.
I should memorize the quote for it. So once upon a time and long, long ago, I was approached by a movie studio saying, we need you to tell us everything about tornadoes. And I said, okay, sure, I can do this. He said, yeah, we're going to have things exploding out of the tornadoes. And I was like, okay, can I find out what? Nope. Okay, cool. We're going to have things coming out of the tornadoes. Let's talk. And I gave them my whole big list of here's how tornadoes work, what to expect from them, and like water spouts and like how you can have hurricanes that spawn off tornadoes and all of these things, how they can pick things up and how they drop them in the thermodynamics and everything else. And I gave it to them and they disappeared with it. And roughly speaking, a year later, Sharknado came out. And I went, wait a minute, I know that studio. I have a paycheck from them. Did I work on that? And I had no idea. And I didn't know for several years. So for a long time, it used to be one of my favorite trivia questions. And they're like, tell us about yourself. And my answer would be, I may or may not have worked on Sharknado. And I don't know. And then I finally watched it. I mean, I'd heard about it enough. I had to do it. I watched it. And there's one sentence that is verbatim from my notes that I sent them. So it's that one sentence that I wrote about how, like, it's literally like a little definition thing about this particular type of event, this jargon term is, and then the definition of what it is. And that's all it is. And it's perfect and beautiful and accurate in the joy that is Sharknado. And I have no idea why it exists, except for maybe for contrast. Like to have that little bit of salt in your cookie dough so you get the taste of sweetness. And if you don't have the salt, you don't get it. I wonder if that's what it was. Or like,
yeah.
Maybe,
I think when they made Sharknado, I think they had already embraced the idea of doing a ridiculous disaster movie, obviously. So they had to have that in there just so everybody would kind of realize how ridiculous it was.
I totally if they like hired me in order to have a list to do the exact opposite of every single thing on that list. Like, I don't know. I genuinely don't know. And I'm dying to ask. Like, so.
You should call them one day and find out and say, did you want to know that so you could do the exact opposite of everything on the list?
Yeah, like what was the purpose? I don't know, but I love it. So whatever, it's fine by me. There's been all sorts of things I've worked on where the motivations were not what I first assumed. Like, I worked on Stargate. On that one, it makes total perfect sense. You've got a sci-fi movie or TV series about like traveling through the wilderness and like going and exploring other planets. Of course, you would have a field scientist that you'd ask questions to who knows some astronomy along the way. Like, this is completely sensible. And like working on Star Trek Discovery, again, it was like they needed a disaster and they needed to talk to a disaster person. Fantastic. I get this. I worked on Madam Secretary looking at permafrost melt and geoengineering. I teach geoengineering. I work on climate change sometimes. Again, I'm Canadian and there's a lot of permafrost here. I get why they want to talk to me, and I get why they want to have some real life grounded policy science about climate change in their show. Like, totally sensible. And then there are times that confuse and delight me. I worked on No Tomorrow, which is a romantic comedy about the end of the world, where a giant asteroid is coming to kill us all. It's very cheerful. It's actually seriously cheerful and fun. It's on Netflix. I totally recommend it. It's a 1-season show, where they had me write an entire thesis as a prop. Like, it's an actual complete thesis with references and figures, and like I collected data, everything. It is a thesis for a fictional asteroid. It's amazing. It's genuinely amazing. I have a chunk of a trailer has my math in it, which was my first time ever being in a trailer. But the reason is that the producer of the show really is a huge supporter of doing near Earth object tracking and sees this as a completely 100% preventable disaster where all it takes is time, money, and dedication on our part to prevent this entirely. And his reasoning was, if we can get this science kind of inserted into a show of people who would classically not pay any attention to science, a romantic comedy, then maybe we can start building some awareness and support for it. And I mean, I just loved that concept. It's subversive education. I'm down for it.
So let's see. So let's think about some more fun things. I know which one I want to end with. So following some stuff in the middle. How about the one of the things that Pamela and us in Astronomy Cast and stuff often want to talk about are the massive supervolcano underneath Yellowstone. And so how about you tell us what you think might happen with that?
All right. So Yellowstone is something that I like. Every time anything happens at Yellowstone, people freak out and panic a little bit. And it can be over things like some of the seismometers stopped working. Except you're talking about incredibly delicate, fragile, high sensitivity science equipment that's left outside 24 hours a day, 7 days a week, 365 days a year for years on end. Yeah, they break. It's part of the deal. All geophysics equipment breaks. It's why I tease that our job is like half Bond villain and half MacGyver. Everything breaks. So yes, seismometers are going to break. They will need maintenance, particularly if we've had government shutdowns. We're really going to need some more maintenance happening. People get scared because of animal migrations, which animal migrations happen several times a year, every year. It's
generally in the same places.
Yeah, it's a thing that they do. It's kind of. I'm sorry you didn't pay attention to them before, but they're doing what they usually do, and you're just noticing for the first time. Congratulations, it's amazing. Sit down and enjoy the webcam. Or they get upset that the roads are melting. Okay, I understand that's a little bit unusual to have melting roads in most parts of the world. But when you've put asphalt over a place that has hot springs, you might be able to assume that the hot springs mean the ground has some heat in it. And right now we're looking at on Mars, we've got the Mars Insight lander has a heat flow probe, the mole, and they're desperately trying to get a hammer into Mars, and it's doing exactly what every heat flow probe I've ever worked with has done, which is malfunction and refuse to do what you expect it to. I've never had a heat flow probe go smoothly. But if they could, they're going to be able to figure out the thermal gradient on Mars. Well, the thermal gradient at Yellowstone is quite high. It's warm. It's very warm. That's why you have hot springs and why you have geysers. It's the whole reason it's a beautiful park you want to go to, which means that, yes, the roads melt every now and then, and it's part of the yearly maintenance to fix the melting roads. So people worry about these things, and quite honestly, they're the normal things that happen all the time. Same with earthquakes. There's small, low-level earthquakes all the time because there's all that fluid that's moving around underground, and as it's moving around, things wiggle. It's if you have a glass and you swirl it, the glass moves. It's what happens. So every time there's this big Yellowstone is about to erupt thing going on, I'm going, all right, let's check the USGS website, Yellowstone Observatory. Oh, normal. Everything is normal. So I understand people get scared, and I hope that every time they do, we have this little chance to reach out and go, hey, actually, this is super cool, and it's all fine. And if things actually start getting scary, we're going to have some warning, because magma takes some time to move around in all those underground chambers and everything and actually get ready to erupt. We're not there yet. It's cool. It's good. Just bask in the wonder and the awe. Just bask.
Well, I have to say I'm happy to hear that because we have people that want to take a trip there, and we were all like, is it getting worse? Glad to hear that. No, it's time for us to go and enjoy this area and the unique situation.
Totally.
Okay.
Oh, have fun. Much better than doing volcano tourism. Volcano tourism, much more terrifying. Even the ones that are well behaved, anytime they burp, like any just straight up gas, well, that gas can be hot, it can be toxic, it can carry volcanic ash, where volcanic ash is tiny shards of glass. It can carry debris, pyroclastic debris, which is chunks of broken glass and hot rock, and send it flying. And because it's just a burp, it's just like a little bubble of gas, it doesn't have any precursors, it doesn't have any advanced seismic warning or anything like that. And unfortunately, we just had that happen at White Island in New Zealand, and it was a pretty devastating event. And because pyroclastic flows are hot air, hot gas, they're less dense than water, so they flow down the mountain and then across the ocean, which made for, again, a terrifying experience. And I highly recommend against watching any of those videos. There's a lot of disturbing about that, and it's something to keep in mind if you're ever doing volcano tourism, is it can't be safe. It's inherently a risky proposition. It can be beautiful, it can be awe-inspiring, you can get lucky, but there's no such thing as a safe volcano. So that was cheerful.
That's cheerful. No, we need something cheerful now. So one of the questions that keeps popping up in the chat is people want to see your traveling companions.
Oh, I have so many of them. Okay, right here. So you have Moose here. And then on the other side of the camera, actually making sure I don't accidentally, I always have the reverse side of my camera has a small animal there. So there's Fluffy.
Hi, Fluffy.
Oops. And now I've completely killed the camera. So that's always up just in case I accidentally broadcast backwards. So here's Fluffy again. And then one moment while I grab the rest. Yay, there's a lot of them. I don't know if we've ever done all of them in one go. We have, of course, Toothless, who has very rarely traveled with me because he tried to run away in Colorado one day.
Oh.
Piper's been on timeout since trying to stay at the Strand bookstore in New York, so can only travel around Vancouver right now. Puff the Science Dragon has a claim on all hack days. Last hack day was Science Hack Day in San Francisco. Murphy joined me in Florida at a rocket launch, and then most recently, just did another big event with me. I think went to a series of foo days with me. Trixie's Triceratops was at the end of the Juno mission. Astoria is currently keeping an eye on Betelgeuse for us to see whether or not it fades out. Oh, there's the other half of this duo. This little pair have not actually gone on any travels yet. They've just come home with me and are waiting on their first trip. Glom was living on a boat for most of the last year, but did just come back and rejoined me after a quick trip to Disneyland. And that leaves our final friend here, who would like to warn you that it can be very scary out there. And I think that's everybody who travels with me. One who's never traveled with me is Griffith, who mostly hangs out and reads physics books. So it's named after Griffith, the physics book author. So there we go. I guess Moose has been photobombing me the whole time here, which, that's his right.
Moose do that. They like to come and photobomb.
Exactly.
No.
I love that now I'm like scattered with teddy bears all around me. It's my plush adventurekin.
So if they all go, that's a big bag just to carry them.
Only one comes with me at a time.
Okay, one at a time.
So
Okay.
This is the most frequent companion who's been traveling with me now since I was, I think, 16. So Moose is like old enough to vote, to rent cars. He can do all sorts of things at this point. And then, as I said, these two are the newest, who just joined me in the last 6 months, not even. I think they joined me this summer. So it's a slowly growing horde. Trying to keep track of them all is challenging sometimes. This is actually the first time they've all been in one room in about 3 years. So,
well, I think everybody in the chat is just delighted because they've never gotten to see them all either. But they knew you had them, so that they were definitely asking.
Makes me glad I brought them all into one room.
You brought them all in. So you mentioned Beetlejuice. So tell us, Beetlejuice, Beetlegeist, whichever is the appropriate pronunciation, because I heard Pamela saying it both ways earlier.
I would trust her more with the pronunciation. I will fully admit that I lean heavily on my hybrid Canadian Californian to be like, oh, no, that's just a regional thing. We leave the house, go out and about now, to Beetlejuice. It's on a boat.
Very true. So what do you think may be going on with Beetlejuice right now?
Oh, I think we're about to learn something new about red supergiants. Like I think that there's always more to learn, and there's so many things about that particular star that are so deeply confusing. Like, it's too small, it's too cold, it's rotating way too fast. It might or might not have eaten another star. Like, excuse me, shouldn't we know if it's a cannibal? I feel like we should be able to tell. Like, it should have a little cannibal sign over the top, just labeled it.
Let me interrupt real quick. I apologize, but we just got a raid from One Girl, Two Beakers. So thank you so much, all the raiders coming in. You are watching the CosmoQuest Hangout-a-thon, where we are trying to raise money to do science. And we are here with disaster scientist Mika McKinnon. And right now we're talking about how the red giant star Betelgeuse is acting really weird and suddenly is much more dim than it used to be. So
yeah,
let's pick up there, because welcome raiders.
Yeah, so we don't know what's going on with it. It's too cold, it's too small, it's too fast. It may or may not be a cannibal. And we never really understood why it did this whole brightness variation in the first place. Like, there's a lot of theories and a lot of ideas and a lot of models, but there's a lot of things we're like, well, that's interesting. I wonder what else it's gonna do. So we know it's gonna go supernova eventually, and on geologic timescales, it could happen like any minute now. Astronomical timescales, it's like going to happen in the next eye blink or two. But human timescales, is probably going to be a while, probably. And if it does, we're going to get a precursor from all those messenger particles first. So it's going to be an invisible wave of high energy particles that will hit us first, and we'll suddenly go, ah! And like every astronomer on the planet will start screaming and waving their arms around and get really, really excited, because it would be the closest supernova, but not so close it would hurt. It would do nothing to Earth except for be pretty. So we get to observe it really, really, really well. In fact, it would get so bright, it would be about as bright as the moon is. So you could see it during the daytime, like a little star out there, just hanging out, day star. and we'd have like all this amazing equipment. We could whirl around and point at it and find things out. And we haven't really had a close supernova since 1987. And even then, it wasn't as close as this is. So I don't think it's going to go supernova anytime soon. Like, I wouldn't bet on it. I won't clear my calendar. But it would be pretty cool if it did. Like, it'd be genuinely interesting without actually being dangerous, which is, to me, the perfect combination for a disaster.
Absolutely, because that was one of the questions I had was, is it close enough that it could cause any problems?
No, like, it wouldn't even impact cell reception, which is kind of amazing. So this is something you don't think about as I just graded a bunch of geophysics finals because 'tis the season, right? And one of the things that you have to pay attention to in geophysics is you actually need to check the space weather reports before you go out and do your surveys. Because if you're doing a magnetic survey, not only can you not wear blue jeans, because blue jeans have all those metal rivets, and that could be enough to mess up your survey. So you're like, okay, who's got some canvas pants? Corduroys? Anybody got corduroys? Let's do this. No zippers. We got to go 1970s button flies on everything. And you have to get the shoes that don't have any metal at all. So you're looking at like Toms to have the purely canvas top, like no metal rivets on them. Leave your cell phone for sure. But you also have to check the space weather, because if you have a big coronal mass ejection or any sort of particular disturbance from our closest nearby friendly star, the sun, it can be enough that it causes so much noise and so much variation from the like global magnetic field that you can't do a localized magnetic survey to say find that oil drum that somebody buried in the 1960s and then forgot about. So yeah, you have to check your space weather before you can do your magnetic surveys. But if Betelgeuse explodes, won't make any difference. We will not need to pay any attention to it.
We'll just get to look at it and say it's pretty.
Exactly. It's the ooh pretty disaster.
That's probably the best kind.
Oh, I love ooh disasters.
Yes.
They really,
All right.
really best.
All right. This is what I've been wanting to get to. Tell me about the unsnap.
Right. Okay, so from a disaster perspective, to have the snap itself and you lose half your population, you've got problems from that. Mostly having to do with things like we have just-in-time shipping at this point. So it used to be a couple of decades ago, you'd have warehouses full of stuff everywhere. You'd ship this stuff and you'd have it nearby, and then you distribute it to the stores or to the manufacturers or whatever, whoever needs the stuff. But we've transitioned to just-in-time logistics. So you don't have those big warehouses of things. Things stay in warehouses only for a couple of days at most, where they're being sorted. Instead, things are where they're originally manufactured and they just get manufactured on demand and moved to where they need to be. But if you lose half your population and you can no longer deal with running things, you're going to have this massive supply chain interruption, and you don't have on-hand resources, and you're going to lose things like your food is not all going to be where you need it. Like, you'll still have food growing, but you won't be able to get it in from the fields and then distribute it out to the places that need the right types of food. You'll have the wrong types of food in a couple of places and not be able to collect it all anyway. You won't have enough people to be able to run all of your power stations or water stations or anything like that. So after the snap, you then get the secondary disaster of everybody dies of dysentery. Which quite honestly would be a very unpleasant way to go, of all the hygiene issues, of all like the disease spreading, the starvation issues, just like big ugly. But all right, we fast forward a couple of years, everything's restabilized, everybody's going to grief counseling. Nobody is a trained grief counselor, so it's all a little bit iffy. They're using some kind of bad practice in this. And there's some people who are really, truly awful at helping each other with depression, which was heartbreaking to see. But then we have the unsnap and we bring them back. All right, great. So now they're back in a world that has reduced capacity to meet half of that demand. And unlike before, when the food was in the fields and you just couldn't gather it all, the food does not exist at all. And it's not even that you've rebuilt to deal with half your original population, is rebuilt to deal with less than half because you had everybody dies of dysentery. So you're rebuilding of effectively you've tripled to quadrupled your population instantaneously overnight with nothing to feed them. And your resources, you don't have enough places to put them because you've had to retreat. So that whole thing about advanced retreat, hold the line, do nothing on our disaster preparedness scales, you've had to retreat and concentrate your populations in order to mutually support. Which means that then you don't have, like, the outer areas would then be abandoned and not maintained, so they're not move-in ready. So you don't have anywhere to put them, you don't have anything to feed them, you don't have the capacity to hold this sudden abrupt doubling of your population, except for it's more like tripling or quadrupling of your population. Oops. Da-da-da.
There you
Sorry
go.
about that. I had a slight power glitch happening here. Yeah, and then they of course have not had that huge traumatic experience. Like, for them, it appears time was just frozen and then restarted with no intervening time. So all of your relationships, like your friendships, your romantic relationships, whatever else, are trying to bridge this gap, this gulf of massive disparate experiences, lived experiences, and you're still going to have to then deal with the secondary wave of grief of everybody who died of dysentery, who did not come back. And then the survivor's guilt going on of, like, well, I got to skip all of this horrible stuff that I'm now reprocessing 5 years behind you, whereas you had to adapt to life without all of this and, like, have that acceptance of grief. And the people who died who's not in either of those categories, like, it's just, it'd be ugly. It'd be real ugly.
And this is why we won't have a movie about that, because that would be really depressing.
Yeah.
Frustrating.
No, I when it came to the Avengers, the only thing I dealt with was the Infinity Stones. I talked about pretty rocks with them, which is way less depressing than doing the disaster management side. There are some
This
things
is
that
true.
want to have a good story. You have to be willing to just kind of go, all right, let's just smooth that on out and keep going.
Let me look and see if we've got any other questions for folks. Let's see what they're saying. Mostly they're saying things like it would be like an Oregon Trail experience.
Yeah.
Just everywhere.
It would. It absolutely would be. Like, and this is one of those things where I'm like, okay, so I'm part of the Oregon Trail generation. I am that little tiny gap that grew up and had, like, the green screen computers and played Oregon Trail in school. And then, like, that ended and the next generation kind of kicked in. So I'm an elder millennial, I guess we're called now, but I'm the Oregon Trail generation. And every time we're dealing with disaster stuff, I'm going, oh, remember Oregon Trail. Like, this is why we have pasteurized milk. Like, what are you doing with this, like, raw water? Do you want to die of dysentery? This is a terrible idea. This is, like, no, I mean, come on Oregon Trail, we packed our disaster kits and we, like, went across the wilderness and went, let's go do this. Everybody knows you don't Ford your wagon. Like, we learned things and then apparently forgot. And it drives me absolutely bonkers. Like, but we already did this. We had an incredibly popular game about disaster preparedness. Why don't you remember with me?
So Finn Mill asks, if I'm too old for Oregon Trail, does that mean I won't get dysentery?
No, it means you're more vulnerable to dysentery because we're also the last generation that had the crappy vaccines, and everybody who's younger than me has better vaccines, and I am annoyed at them for that. I had shingles. And everybody younger than me doesn't get shingles because they didn't get the live vaccine. They got a way better, higher quality vaccine.
I'm 1 year away from getting the shingles vaccine, and I'm happy about that because I'm like, I want that vaccine because I don't want to get shingles.
That's for deeply unfair because I've already had shingles. My risk of getting shingles again is exactly the same whether I'm vaccinated against it or not. And I'm just like, I'm going to pout. I'm just going to seriously pout about this. This is not fair.
And my kids never even had to have chicken pox. So,
so
they don't have the virus.
Yeah. So I'm envious of everybody younger than me for having better vaccines. And the people older than me, you get to join me on the dysentery trail. So, kids these days, with their high quality vaccines and their parents who don't vaccinate them. It's a terrible combination.
Absolutely. So let's see here. Russ Matt says, I used to play Oregon Trail on the computer, and now I use my computer to 3D print the Infinity Gauntlet, but not the same computer.
It would be very impressive if it was the same computer. I'd be slightly disturbed and go, okay, well, I guess actually technically I have a Raspberry Pi emulator around here that can still play Oregon Trail somewhere. I think it's over there. But yeah, so connections between Oregon Trail and the Infinity Gauntlet, just because we can. Everybody dying of dysentery. Other things inside of Oregon Trail. So doing the risk assessments on how, like, do you keep hunting or not, and whether or not, like, how much stuff to carry with you, and how far you can go. All of those are concepts of what is your local storehousing or capacity to supply the number of people you have. And it's something that, again, we've changed what our perspective on that is, where we used to do the local storehousing and now we don't. And it's economics, but it's also really like huge impacts anytime there's disasters. There's a couple of years back, we all had our solid state hard drive prices jumped because of floods in Thailand. And that there's all sorts of weird price things that happen like that when you've got a disaster somewhere else in the world. So you can think of every disaster as being a local event, but in a lot of ways, every single disaster will impact other people, other places, right? This week, we've got freaking Australia had to recolor their weather maps, and it's purple now because it's so hot. It went off the top of the scale, and they're just cycling back through again, starting at purple, and are going to work their way up. Like, I am not looking forward to blue hot.
You're supposed to see that on natural gas, not on a weather map.
Exactly. Yeah. Like, these are not supposed to be true to life. Australia is now all on fire. All right, so what impact does that have anywhere else? Well, that ash then comes up, it starts getting spread in the upper atmosphere, it comes back down again, that then triggers rainfall in other places. But one of the things I constantly tease about, and is that when Australia gets drier, where I live in the Pacific Northwest, gets wetter because of how our particular weather cycling is happening. So this year we're getting like ridiculously damp, and I'm worried about my hair mildewing. That we get these switches that happen. It's every disaster is inherently local, but every disaster is also inherently global. It will have its impacts everywhere else. You'll feel it in other places, even if you don't quite recognize what those connections are.
So one last question from me, and it's probably not a happy question, but it's one that's good for your expertise. So are we seeing more disasters happening, or are we just seeing the ones that are happening being more extreme?
Yes.
Both.
That's either question that's happening both at the same time.
Yeah.
So there's an element of, we are recording more earthquakes now than we used to because we have more seismometers, and seismometers are more sensitive. And those earthquakes have bigger impacts because we have more people in more vulnerable places. But we also have things like, because our climate is overall warmer, we've put more energy into the system. When you have more energy in a system, you're getting an instability from that. So you're getting more storms more frequently that build up faster into greater intensity. You get the hotter hots, you get the wetter wets, you get the colder colds, you get the drier dries. Like, everything gets more intense in different directions. And it's all miserable. Like, it's all just the worst experiment we could be running. I have, not in this room, so I can't grab it quickly. I have a couple of rocks that I carry around with me as reminders of what could be, and that it's never too late to make things less bad. So once upon a time, and long, long ago, about 1 million, 2 million years after a billion and a half years after the beginning of the Earth, there was a blue-green algae, cyanobacteria, that grew up in shallow, warm water. And they grew in these mats, and it got sediment inside of it. We call them stromatolites. And they grew up, and they were like knee-tall mushroom-shaped things. And they breathed out oxygen. Breathed in carbon dioxide, breathed out oxygen, and they breathed out so much oxygen, they oxygenated the oceans. And all the iron in the oceans rained out in layers of rusty, non-rusty, rusty, non-rusty, into banded iron formations. And this rock only happened during this time period. It is an extinct rock. Its formation conditions cannot happen anymore. We now have an oxygen atmosphere. We already oxygenated the ocean. We're done with that. But stromatolites kept going, kept breathing out more and more oxygen, and they oxygenated the atmosphere. We call this a great oxygenation event, but we also call it the great oxygenation catastrophe. So from our perspective, it's fantastic. It was the start of the Cambrian explosion. It was this huge diversity of life. It created, like, it led to the evolution of all the things that eventually turned into like humans and cats and dogs and hedgehogs, and everything adorable on this planet came originally from this like massive experimentation of life. But from the stromatolite perspective, they were so successful, they fundamentally changed the inherent atmosphere of the planet into something that was toxic to them. And they killed themselves off. And there's a tiny pocket of them living in Shark Bay, Australia. They adapted and survived. And there's a couple tiny pockets in places like Jamaica that have also managed to adapt and survive. But the vast majority of stromatolites died and are now fossils. And I went and visited one in a blizzard. I went and did a road trip in a blizzard and like swept the snow off of them and like pet them and thanked them for their oxygen. Because hey, without stromatolites, I wouldn't exist. I owe them a debt. Thank you. But at the same time, they killed themselves off. They were so successful that they died. And I just think, I just want us to be smarter than LG. Like, that's it. My entire ambition. I want to be more strategic than a stromatolite. That's all.
And that is probably a good lesson for us to end on. Everybody remember that. We want to be smarter than a stromatolite.
Exactly.
Sometimes it feels like there are people in charge who aren't smarter than a stromatolite, but we want to be.
Yep. It's
So
never to make things less bad. We don't
exactly.
need them perfect. We don't need them great. We just need less bad. And it's never too late to make things less bad.
Yes, I agree. So why don't you tell us all the places you can be found?
All right. I am on Twitter as Mika McKinnon. First name, last name. That's all. I'm pretty much on every social media like that somewhere sooner or later. Upcoming events. I will be at ComSciCom in Texas, in Houston in January. I'm doing a TEDx talk in Bingham University in New York in springtime, sometime. I don't know, March maybe. I'll do GateCon in Vancouver in August, and probably DragonCon. I don't know yet. There'll be more events. They show up. I don't know what I'm doing in 2020 yet. It's a long way away.
It's like a long way away. You'll figure it out by then.
Exactly.
Well, thank you so much for being with us on the Hangout-a-thon. And thank you all, folks, for watching. Hopefully, some of this information was fun to hear and some was a little scary to hear. And all of it is good to know. That's the important thing. But no, thank you again, Mika. We really appreciate having you. Yes, show us all of your little critters one more time because they're very cute.
They're all joining us. I don't even know how many can fit in here at the same time here, but you know, everybody who can is gonna cuddle up for a minute. Woo! Come on, everybody, join in, join in. Yee! I don't know if I can hold them all. There we go. Yee! Yeah!
There you go.
Really, it's just Moose and his kin. All right, have a fantastic night. Good luck with the Cosmo Quest.
Thank you so much.
Favorite community science programs, and it's so much fun to participate every year.
And we greatly appreciate you doing that too. And hopefully I'll see you at DragonCon because that's where I go every year.
All right.
So bye-bye.
Farewell.
And all right, I am here to see if Annie is ready to pull back to the camera. Annie or Dave, whoever's ready to take back over, because I'm about to go to bed and I'll be back in the morning. I believe I'm talking to Dave Dickinson in the morning. No, I'm talking to Brian Coberline at 11 o'clock in the morning. He's one of our astrojournalists and scientists that comes and talks on the weekly Space Hangout. So I'll be here for him in the morning, and then I'll have Dave Dickinson tomorrow evening, who is another space journalist. And yeah, Pamela gave me the good people that I already knew, pretty much, which is pretty nice. So let me type over here and ask Annie if she's ready to come back on. Here's the typing. There we go.